Hi there, this is Penelope, FS3128, Topic 4, Class 2. We're looking at the third section of algebra. It's very common in the real world to have a problem that requires a solution, and that's part of what you have to do as engineers. Now, if we can translate this problem into maths, then we can use maths to find the answer to our problem. Sometimes, though, what we've created may be quite complicated, in which case then we need to simplify it. And we've spent a bit of time looking at the simplification techniques. We can add like terms, add or subtract like terms. We can put in or remove brackets. We can cancel legally. We can take powers, for example, all sorts of things that we've already looked at in terms of how we can simplify an expression. Now we're going to solve equations. We're going to actually solve an equation, and if it's going to be an equation, it must have an equal sign. I mean, that goes without saying, but it's one of those things that people forget. So an equation needs an equal sign. So an equation is something like this. That's an equation. There's an example of a similar one, or even so to be an equation, it's got to contain something we don't know about. So it's got to have the x in it. It's got to have an equal sign. And most likely it will have to have a solution. But this process of finding the unknown quantity is called solving an equation. And we're going to start in this course with finding the solution of what's called a linear equation. And a linear equation is just where the biggest power is 1. And of course we don't need to write the power of 1. To solve any equation means you've got to find the value of that unknown variable. And then if you substituted that into the left-hand side, it would equal the right-hand side. And there are two ways of doing this. Either we can rearrange so that the thing we don't know is the subject of the equation, or we can play fair and keep the equation balanced. So for the second one, if you look at the picture, if you imagine the picture in your head of what an equation looks like, or a linear equation in this case, what it looks like, you can kind of see what is going on, and you need to do something that will keep it in balance. For example, if you were to take off an x and 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 an x, it's going to stay balanced. If you take off a 1 and a 1 and a 1 and a 1, it's going to stay balanced. Now if you then look at what you've got left, you've got that 2x equals 1, 2, 3, 4, 5, 6, 7, 8. And now all we have to do there is say, well, we didn't want to find 2x, we only wanted to find 1x. So if we again do the balancing thing, do the same to each side. In the instance up here, we took off box for box, or little block for block. We did the same thing to each side. If in here we do the same thing, and here we divide by 2, divide each side by 2, then we have 8 over 2 equals 2 over 2x. So that tells us that 4 equals x, or more normal to write x equals 4. Big thing here is to check 3 times 4 plus 10 is 22 is equal to, maybe, 5 times 4, which is 20 plus 2. So yes, it works. So you do need to check your solution. Let's have a look at some of these. Now, what I want to do is I want to get my x's onto the left-hand side and my numbers onto the right. The first couple I'll do in baby steps. So I'm going to do 1 plus x, that's the question, and then I'm going to add x to each side. Then I'm going to tidy up. Now, the right-hand side becomes 3, the left-hand side becomes 1 plus 2x. I want my x terms on the left and my numbers on the right, so I'm going to take away 1 from each side. So now I've got 2x equals 2. I didn't want 2x, I only wanted x, so I'm going to divide each side by 2, which is 1. So x equals 1. And then go back and check. In the second one, I'm going to take away, no, maybe I'll take away 3x from each side. On the left now I've got 7 equals 3 plus 2x. Now I'm going to take away 3 from each side. So now I've got 2x equals 4. I didn't want 2x, I only wanted 2x, so I divide both sides by 2, and I have 2 equals x, or x equals 2. Check it out. 2x minus 5 equals negative 15 minus 3, so I'm going to add 3x to each side. Tidy it up. So 5x minus 5 equals negative 15. Now I'm going to add 5 to each side. Tidy it up. 5x equals negative 10. I didn't want 5x, I only wanted 1x. I'm going to have to divide each side by 5. Check your answer. The last one will require us to simplify. First we need to get rid of those brackets carefully. So it'll be 4 times x minus 4 times 3. That's even before we started. Now I'm going to add x to each side. Tidy it up. Now I'm going to add 12 to each side. So 5x equals 20. So x equals, we didn't want 5x, we only wanted 1x. So divide both sides by 5 and we get x equals 4. Here are some more. I suggest at this stage that you stop the video and do them first on your own, and then go back and see if you get the right answers. So the answer for the first one should be, don't forget you've paused the video, now restart. The answer is x equals 7, x equals negative 3, x equals, no, that's not right, x equals negative 4. And for the one that's called x number 5, x equals 2, and for the one called number 7, x equals 3. So try each one, halt the video, do it, get the answer, check it.